All right, here's 11 through 20. So our original equation in 11 is 4 over a plus 5 over 3a equals 3. So with these two things, these need a common denominator in order to add them together. So what I did is I multiplied this one by 3 over 3. So that got me 12 over 3a. And then once I have the common denominator, I can combine these into the same fraction over here. So I have 12 plus 5 over 3a equals 3. I can multiply the 3a to the other side. 12 plus 5 is 17. Divide by 9, so a is 17 over 9. All right, these, back to another chapter that you guys had a lot of fun with. So anytime I see a square root, I think about my square numbers. Like 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. 5 squared is 25. I'm going to take out the biggest number that I possibly can. Since this is a square root, I can take this out, and this is 16 times 3. Well, the square root of 16 is 4. I don't know the square root of 3, even though it's 1.732. So that stays on the inside of my square root. Now with this g to the 7th, if I do 7 divided by 2, that is 3 and 1/2. So I take out g to the 3rd, and I'm left with 1g on the inside. Same sort of deal down here, except it's to the 4th power. I know 625 is 5 to the 4th, so nothing left over like there was a 3 on the last one, so I have 5 on the outside. If I do 12 divided by 4, that is 3 even. And if I do 24 divided by 4, that is 6 even. So there's actually nothing left on the inside, kind of like we had a remainder in this last one. Likewise, if I have a cube root, so 5 to the 3rd is 125. So if I do 3 divided by 3, sneeze, don't sneeze, no sneezing, no, not allowed. Okay, so 3 divided by 3 is 1, so 5 to the 3rd, so this is 5 on the outside. 9 divided by 3 is 3, 6 divided by 3 is 2, even. So I don't need to leave anything on the inside. If we are multiplying, you just multiply the inside numbers together. So square root of 18 times square root of 3, square root of 54. The biggest square that I can take out, kind of like what I was talking about earlier, is 9 times 6, because I know the square root of 9 is 3. Square root of 6 I don't know, so I just leave it on the inside. 16, same idea, except it's cube root. So I want to take out the biggest cube I possibly can. That would be 8 times 5, because 8 is 2 cubed. And 8 times 5 multiplies evenly to be 40. So I have a 2 on the outside, a 5 left on the inside, and then looking at your variables, if you do 13 divided by 3, that is 4 and 1/3. So I have 4 a's on the outside and 1 left on the inside. 15 divided by 3 is 5 perfectly, so we have b to the 5th on the outside. Another cube root. So the biggest cube that goes into 192 is 64. That is 4 to the 3rd. So I have a 4 on the outside, a 3 left on the inside. 64 times 3 is 192. 10 divided by 3 is 3 1/3, so I have 3 and 1 left over. 6 divided by 3 is 2, so b to the 2nd on the outside. All right, still multiplying, so we're just multiplying the insides, and then we'll simplify this thing if we can. So cube roots, so again, multiply the insides, so 3 times 8 is 24, x to the 4th and x to the 7th is multiplying 11 x's all together. 24 is 8 times 3, because 8 is 2 to the 3rd, so I can say that this is 2 with a 3 on the inside. And then if I look at the 11, 11 divided by 3, since we have a cube root, is 3 and 2/3, so I have a 3 on the outside, and then the 2/3 is still left inside my cube root. So same idea here, 75 times 6, so 75 times 6 is 450. The biggest cube that I can take out, I should actually have, oh no, this is squared, yeah. So there's understood to be a 2 here, so I'll divide all my exponents by 2. So the biggest square I can take out is 225, that is 15 squared, and I'm left with the 2 on the inside. 8 divided by 2 is 4, 15 divided by 2 is 7, with a remainder of 1 left on the inside. All right, and looking at 20, I might as well do through 22, why not? So with this one, as long as the roots are the same, I can just add these things together. So I have 5 in the 4th root of 3x, so 5 plus 5 is 10, 4th root of 3x. You keep that the same right there, you just have the numbers in front, so that's how many of those things you have. All right, garden has this width, what is the perimeter in simplest radical form? So the perimeter, we have of a rectangle. You add up all the sides, length plus width plus width. So if I have 2 root 13 plus 14 root 13, 2 plus 14 is 16. Like I said, keep the square root the same. All right, simplest form here, root 175. So what I did first, and what we need to do, is see if we can get these all to be the exact same. If we can, then we can just add those things together. 175 breaks down to 25, which is 5 squared, so I have 5 on the outside, 7 left on the inside. 28, the biggest square I can take out is 4 times 7. So a 2 on the outside, 7 on the inside. 7 is just 7, so 5 plus 2 is 7, minus 1 is 6, so 6 root 7 is our solution. All right, I'll make another one for 23 in however long I feel.